because this video is supposed to be out already. But, you know, we got busy during the first week of school trying to reacclimate ourselves to figure things out. So, this video will be mainly served as a review of things that we have did before. All right? All right, number and quantity. So, on your ACT, this is what you have to deal with. You are being tested on your ability to apply real number and complex number systems in various forms by including integers, irrational exponents, vector and matrices. So the stuff I highlighted in red, that is something that you will be dealing with your senior math teacher. This is not a junior math topic. However, if we get lucky, I'm going to sneak this in right here. Because this matrices is a very fun concept. Don't just take my word for it. And I promise you, you're going to love that. But the vectors, that's something that your senior teacher would touch on. And I would sneak in matrices. Alright, announcements. In these videos, I'm going to try to keep the announcement and all the other informational stuff, condensed. So I'm going to cut most of that out when I'm trying to teach stuff to you. Announcements. When you are absent, you are responsible for your education. So that means that if you are absent, I I do a good job with keeping stuff online for you to do. Just do it. You know? Even if it's stuff for the whole class to do, you still do it too. And just sit back and say, hey, I was not here, but I did the assignment. Alright? Whatever you miss, watch the videos or Google Classroom to get the missing details. You know? Because again, I try so hard to provide online material for you guys to review and practice. Alright, when you are absent, you only get 70% of the material that's being taught. Because the other 30, unfortunately, you have to be in school for. Again, when you are absent, you only get 70% of the material. So that means that you have to be good friends to get with someone to get the other 30%. Alright? So, long story short, just come to school, y'all. Even when you don't feel like it. Reminders. I cannot stress this enough. I'm going to constantly remind you of this. You got to pass the ACT math with a minimum score of 18. That means you have to get 25 questions right. Well, that's what you should be shooting for. In the classroom, I have a an anchor chart that tells you how many questions you have to get right to get to the 21 or the 18. To fully prepare for ACT, you have to use Math Nation. Again, Math Nation. And what I'm going to start doing, you know, when we get back for the MLK break, is we're going to do a little ACT time with Math Nation. This week, well, no, that's considered last week. I gave you handouts and we practiced the ACT stuff and review, which is true. We did do that. But in terms for your homework, I want you to do Math Nation. And I'm going to aim it towards that. The ACT is graded like a final. So all I'm saying is, when you pass the ACT, depending on your score range, well, regardless, if you pass the ACT with a minimum score of 18, you don't have to take the final. You'll be done. You'll be excused from it. And don't forget about all my other perks. If I didn't tell you, just for a reminder, to be excused from homework and tests, you gotta hit that 21. And to get that 21, you have to get 30 questions correct out of 60. If you fail this ACT, which again, you got a chance to take it in March, and you got to take it again in April. Make sure you guys are registering and taking the ACT and passing it. But if you fail it, you guys got a 100 question final. It's going to be bigger and longer. Those who took my fall final, you already got a taste of what that was like. That ACT math, it is 60 questions, and you have 1 minute per session. 1 minute per section. All right? All right, so now let's go ahead and get into all of this. So on the ACT, you gotta know these basic definitions, which you should have known by now. A real number is any number that appears on the number line, whether it be positive or negative. This includes fraction, rational, whole numbers, and zero. So again, you guys know this by now. You know that the N stands for natural numbers. And when I'm saying natural numbers, these are numbers that you have learned when you started counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yay! So those are those numbers. Integers. You know of zeros in the natural numbers, but um, in middle school, you worry about this a little bit more. Integers, you deal with not only just positive numbers, 1, 2, 3, you dealt with -1, -3, -5, negative a million, and all those things. So yes, that's middle school math. Upper elementary and up to now, we dealt with the rational numbers, which is denote Q. So listen up. You guys know fractions, right? Like 1/5. Well, remember I told you in the beginning, we call fractions rational numbers. And it's because both the numerator and the denominator are integers that can be divided. So when you see the fraction symbol, that slash, of course that's always associated with division. However, for it to be a rational number, P and Q, and P and Q is just letters that denote any number I want them to be. Q, Q, the denominator cannot equal 0. Because if it equals 0, it's undefined. Alright? Before I deal with the real numbers, let's do one more thing with the rational numbers. So, 1 is a rational number because every number or every integer could be rewritten as a rational number, like 5. 5 could be rewritten as 5 over 1. These are essential to know, y'all. Alright, if I'm going too fast for you, you could slow down the video or replay it. That's the beautiful thing about, me recording myself doing these lessons. So when you guys are struggling, just click replay, rewind. So real numbers, again, are just numbers that you see. If you put these in decimals, you will see them like, you will see pi on the graph, you will see 1/3 on the graph, you will see 2, 0, -3, and the list keeps going and going and going and going and going and going. Alright? Now, let's talk about the non-real numbers. Now, on your ANET test, you should have these down pat already. So, a complex number C, as we denote in mathematics, is when you are given a part of a real number like 5 plus or minus a imaginary number like 2i. That I denotes imaginary. So therefore it is a complex number. It's not real. Now, for it to be, now there are going to be some situations where you're dealing with imaginary numbers like I squared, and you would think, oh, that's just imaginary. Guess what? It's not imaginary. It's actually a real number. When you put this in the calculator, I squared, you're going to get -1. That's how you could tell it's a real number. However, when you have like -9, for example, we know for a fact that -9 is imaginary because we know the square root of 9 is 3, which is a real number. However, because that negative sign of the square root makes it I, and because it's attached to the 3, therefore it is imaginary. Anything divided by 0 is not associated with imaginary or real. It's just undefined. So that shouldn't be worrisome. Again, you have a number that is attached to a I or I by itself. It's imaginary. It's not real. Imaginary. And yes, I'm doing this with a mouse, y'all. For some reason, I have a bad habit of not using my pens because I tend not to keep up with them. So, again, anytime you have a number that's attached with the I, it's imaginary. But if you have a real number like 7, plus, minus, subtract, or divide by a imaginary number like 3i, because the I is attached to a 3 but not to a 7, this is known as a complex number. Alright? That's known as a complex number. Complex numbers are part and real. And imaginary numbers just are I, or I attached to a real number, therefore it makes it imaginary. Are we good on this? Again, complex numbers have a real number plus, minus, subtract, divide by a imaginary number, which is I is attached to the 3, so it's imaginary. Imaginary numbers is just I attached to a number or just I by itself. However, let's not forget, if it's I squared, it is just simple, just -1. Alright, I feel like I talked enough about that. I think you guys got it. If you don't, just come see me and we could go a little bit further than that. Okay, absolute value. I know it's been a while since I dealt with absolute value, but you have to try to recall it. So absolute value is just a distance from 0. Like if I was to say -4, -4 being right here, well, the absolute value from -4 is just 4, because it's 4 units away from 0. If I said absolute value of a +4, I'm 4 units away still from 0. However, if I have a negative sign, pay close attention, a negative sign outside of the absolute value, you're going to have -4. So usually two negatives make a positive, right? But you see a negative here on the I side, is going to make it negative. All right? This is something that happens rarely when you encounter such a situation. Okay? All right. So, let's do this right quick. So this is what I need for you to do. Try to do this honestly, meaning that you do this yourself first. And then let's compare notes. So pause the video and do these few problems right quick. And I'll be back. Hopefully you have paused the video. If not, pause and do these problems. But if you did, let's compare our answers. So the absolute value of negative 102 is 102 because it's 102 spaces away from 0. 99, 99 spaces from 0. Absolute value of negative 63 is just 63. Again, unless I got a negative sign, I saw the absolute value is going to be positive. 102, 102 spaces away. All right? This is how you do just that. Now, in the ACT, mind you, it's not going to be just so simplistic like that. Okay? All right. More definitions. Again, these are definitions that you do know. And then you're like, Mr. How I don't know this. You're not telling yourself the truth. You do know it. You just gotta remember it. A multiple. A multiple that results from a product of two other real numbers. Like for example, if I was to say 28, 28 is a multiple of 7 and 4. Right? So 28, if you want, or we could go this. The multiples of 3. 3, 6, 9, and 12. Those are multiples of 3. Because go 3 times 1, 3 times 2, 3 times 3, 3 times 4. A factor, which we should know this, results when you divide by two other real numbers. Like for example, if I have 12x minus 4, and remember the greatest common factor? To find the greatest common factor, obviously you just divide by, when you do your list, divide by 4. And when you divide by 4, you realize that 12 divided by 4 is going to be 3x. And negative 4 divided by 4 is going to give you 1. So again, factors is just result for when you are dividing from two other numbers, like we just did. A prime number is when you have where you have a real number that has only two factors, one and itself. For example, 7 is a prime number because 7 times 1, and you only have two factors multiplied together that could give you 7. I know many of you guys are under the misconception that it's all about odd numbers. So like, you guys for some reason like to say 9. 9 is not a prime number because 9 times 1 does give you 9, but also 3 times 3 gives you 9 as well. Therefore, it's not a prime number. 9 is a composite number. All right? Prime factorization. You are simplifying until you have a prime number. For example, if you guys remember how we try to break down the square root of 8, so when we break down the square root of 8, of course we keep breaking it down until we find prime numbers. So when we break this down, we get 2 times 2 times 2. 2 is prime number because only 2 times 1 gives you just 2. However, because we were simplifying the square root, 2 times 2 is 4, and 4 is a perfect square, which makes it 2. However, this 2 that's left over, because it's not a perfect square or anything like that, it's just square root of 2. Alright? Let me do one more example that got nothing to do with radicals. So let's do 20. So when we break it down, we get 4 times 5. Is 4 a prime number? No. So we gotta break 4 down even further. 2 times 2. That's a prime number. 2 is a prime. Also, 5 is a prime number. So guess what? You are officially done. So that's what prime factorization is, y'all. Alright, word problems. So on the ACT, they're going to test you on those things we just talked about, and you just have to apply them to the word problem and just answer the question. So at the gym, Hillary swim every 6 days, run every 4 days, and cycle every 16 days. If she did all 3 activities today, how many days would she do all 3 activities again on the same day? Alright, pause the video and try this out. Pause and try. Alright, hopefully you pause the video or you try this problem on your own, like you tried to do it. You didn't go to Google to try to copy and paste the answer. You tried it from yourself. And guys, just for a reminder, when you are being dishonest with yourself, it's going to show through these tests that you have to deal with. Therefore, you will fail the course. So try to be honest. I know we don't like to be wrong, but you got to learn how to make peace with it. Because this is how you get better with mathematics. Alright, so by now you have worked the problem out, and this is how we figured this out. So, let's go ahead and talk about this for the moment. So what I did, when I looked through all of this, I got 4, right? I got 6 and 16 days. So what I did is just created my multiples of 4, 6, and 16. And what I looked for to answer this question was the greatest common factor. And I realized it was 48. So in 48 days, she would do all 3 activities on the same day. So again, 48 days, she did just that. And again, just list your multiples and go on through it that way. Now, I will caution you, if you go and multiply because I know some of you guys who just multiply and be done with it. 16 times 4 times 16, that gives you 384. So don't just multiply it. I need for you to think about the multiples and find the greatest common factors. And this is the example I was talking about, how they just, on ACT, give you these situations and you have to use what you already learned about factors and stuff. Alright, another problem to try out. Oscar needs to ship 14 rock CDs, 12 classical CDs, and 8 pop CDs. He can pick only one type of CDs in each box. He must pack the same numbers of CDs in each box. What is the greatest number of CDs Oscar can pick in each box? So what I need for you to do, like we did before, try this on your own. I know you don't want to, but you're going to have to, because when you're doing mathematics, mathematics is all about going through the struggle. When you don't understand something, just try it. And then, whatever you don't understand, just, write down questions. Come see me next class period or whenever you see me, and I could gladly discuss it with you or talk to me about it in tutoring. Alright, work this problem out on your own and come back and see me. Alright, hopefully you have paused the video. If you have not, please pause that video and work this problem out. If you have done so, let's see what you got. But if you didn't, please pause and see what you could do first. Alright, this is what I got. Again, with the factors 14, 12, and 8, I found my greatest common factor to be 2, and that's how I went and answered the questions. Alright? So if you need further assistance, please see me and we could discuss the matter. Because you have 3 types of CDs, right? You got the rock, you got the classical, and you got the pop, right? And you try to see how many CDs can you pack in each box. And you just take it from there. But if you need further assistance with this, we could talk about it further. All right, the last thing that is from the ACT stuff is dealing with percents. Percents you guys should be pretty good at, but I got you in case you have forgotten. So again, percents are part of 100. So if you know how to do this, you could fast forward this a little bit. So like for example, you try to find 20% of 45, and you don't forget, percent is out of 100. So that means that when you put this in the calculator in decimal form, like 0.20, this 0 is in the hundredths place when you're dealing with the percent and the decimals, alright? I know many of you guys are under the assumption that it has to be 3 numbers behind the decimal point. If like this is not the hundredths, this is the thousandths place. Because that decimal point right here is understood to be the ones place already. Hear me? Ones place already. Then the 2 is the tenths. And then the 0 is the hundred. This is the thousandths place. So be careful with this. Alright? So let's go ahead and do this problem. What's 20% of 45? So, in case you forgot how to, get a decimal, go 20 divided by 100 and you should get 0.2. And then 0.2 times 45 is just 9%. Alright? All right, this problem is a very, very, very difficult problem. But you're going to try it. But before you do that, let me read it to you. Carrie brought a pack of paper for the math class. When she got to class, she opened it up. Three people asked her for some. She gave a quarter to Christopher. Allison took a fourth of what was left. Then Mark took a third of the remainder. And that left Carrie with 36 sheets. How many sheets were there in the pack of graph paper? Now, I know I got Carrie name spelled wrong. Keri, and it's one R, so I was tripping. So I'm gonna erase that. So we're talking about the same person, Carrie. All right. So what I need for you to do with this particular different problem, going back to your percentages, what we just talked about, try that. Use what you just been taught, and then try the problem out for yourself. All right, go ahead and try it. Hopefully, you have done your problem. And it's okay if you got it right or wrong. I just need for you to get comfortable with doing getting through the mistakes so you're going to get better. I promise you. So if you have did the video, did this problem, and you paused it, cool. If you have not, please pause it and do it then. Click play when you get back. Once you finish, that is. Alright. For those who have did this problem, this is what I got. Now, I got 96. Now, for this particular problem, we're going to talk about, but I want, show you the steps by steps to all this, all that, because I want you to really put some thought into it. All right, so let's look at it. So, when she gives 1/4 is what? 1/4. So, whatever your number that you started off with, try 1/4 times about 1/4. All right, and that's wherever Christopher is going to be. All right, let me slow my roll on this. So, whatever number you start off with, wherever it may be, and I went with 96. I'm gonna work it out for you, y'all. I'm gonna go ahead and do it. I'm gonna do it for you. So 96, and she gave 1/4 to Christopher. So 96 times 1/4 of that is 24 sheets of paper. And that's how much she gave Christopher. So Christopher got 24 sheets of paper. Now we gotta figure out how much is left over. So 96 minus 24 is what? And that's 72 sheets of paper left over. Now Allison took 1/4 of what was left over, which is that 72. was left over after Christopher took his paper. So fourth, according to fourth, it's the same thing. Just letting you guys know that. 72 times 1/4. That's 18 sheets of paper. Alright? So now, I gotta figure out how much is left from that. So, 72 minus 18 is 54 sheets left. Alright? And then Mark took a third from that remainder. Took 1/3. 1/3, 1/3. So 72 times, I mean, it's not 72 because it's 54 what I have left over. So 54 times 1 dash third. And that's just 18. So 54 times the third of that is 18 sheets of paper. Alright? So 54 minus 18 equals 36. That's how much sheets of paper that is left. I mean, that's how we got 36. Alright? So those percentages, let's be careful with those, alright? Let's be really, really, really careful with those. How, when you work this problem out, I am curious to hear what you have to say with your work, and let's just have a discussion behind it. Alright? Trig review. Alright. So, let's just remember our trig. So remember, cosine is the x, and y is the sine value. So keep that in mind always. When you say A and B, guess what? It's still the same thing as cosine and sine. If you saying T and H, it's still the same thing. Cause T and H is not it. No, that's not true. When you say F and G, and the reason why I'm bringing you to this word notation is when you guys take your ANET or what have you, you're gonna be required. You're gonna be dealing with situations. You're like, what F and G? What is A, B, and stuff like that? If it's in alphabetical order like X and Y, think of it as cosine and sine. But Miss Hart, they got nothing to do with that. That's true. It don't. But you know, when you take these weird tests, they like to have a tendency of throwing weird stuff at you. All right. If you're doing good, good job. Let me know how I'm doing with this. I mean, you guys asked me to speak a little bit louder. I'm not speaking any softer, so you got my voice. So just keep in mind all of this. All right. So I gave you guys a question in Kahoot about your radius of the circle being the hypotenuse and the amount. The radius of a circle, in particular the unit circle, is 1. So remember, your radius is also your hypotenuse. Unless I'm telling you it's a 30 degrees, 45, 60, or anything like that, the radius is 1. Now, if I'm asking you for 30, 45, and 60, then the radius will change. But unless I'm giving you the degrees, which in this example, I have not gave you the amount of degrees of this triangle, guess what? It's going to be 1. And again, your radius is the same as your hypotenuse, and that changes no matter what. So for a 30-degree triangle, we know that the hypotenuse of this is 2 for a 30-degree triangle. So 2 is your hypotenuse. Guess what? Your radius is also 2. Alright, you guys should know the unit circle by now. We worked things out already. So we know about the 30 degrees. The 30 degrees triangle, the longest side is on the x coordinate. For your 45 degrees, they all have the same, both the legs have the same value. But for the 60, your longest leg is your y coordinate, which is your opposite left for your hypotenuse. Again, pay attention to this. Alright, so this is what I need for you to do with these angles. We did these before, blue in the face. If you looked at the unit circle, you should know this, but oh, ain't it? You kind of have to know this on your own. There's no unit circle. Again, be aware of academic dishonesty, because academic dishonesty, I make the sole decision of what could happen. Alright? So, 225. In case you forgot how to go from degrees to radians, because I just want you to convert for now. So, from degrees to radians, divide everything by 180. I want you to divide everything by 180. 180 and 180. So 225 divided by 180. And don't forget to hit math. Frac. And when you do that, you get 5/4. And in this case, it's going to be pi at the top. So don't forget to put pi right back. So let's do 300. 300 divided by 180 is 5 pi over 3. So 315 divided by 180 is 7 pi over 4. 135 divided by 180 is 3 pi over 4. Just like that, it's easy with the calculator, but just for a reminder, you guys, when you take the ACT for the district in March, you do not have the calculators. You are not allowed to use them. In fact, I had to probably surrender my calculators because it's just not allowed to have them. They want you to use decimals. All right. Now, with that being said, Let's go find the reference angles of these, which from here is pretty easy. So for 225, we got 5 power 4, right? So what's in the denominator? 4. And we know something about 4. 4 means that the radians, the degrees, is the reference angle is 45 degrees. And we know 45 degrees is the radians of pi over 4. Again, this denominator tells us everything, and it tells us that's 45. Okay, so let's look at 5 power 3. We know for a fact that we look at this 3 in the denominator, it's going to be 60 degrees. I know many of you guys will want to say 30 because it's a 3, not a 6, but y'all don't fall for that at all. We know that 60 degrees has a radians of pi over 3. Again, these others are easy because this is 4 in the denominator, so it's 45 degrees. So it's pi over 4. And then the same thing just repeats again because it has a 4 in the denominator. It's 45 degrees, and we know that 45 degrees is pi over 4 always. Not bad, huh? Alright. Now we got radians and we trying to convert it to degrees. But before we do that, before we do any of that, let's go ahead and find the reference angles of all of these. And I want you to put both in radians and degrees. So we know for a fact anything that has a 4 in the denominator is 45 degrees. And we know that 45 degrees is pi over 4. Alright? So anything with 6, so anything with a 6, we know for a fact has 30 degrees. Not 60. I know you want to think 60 because, oh, it's a 6 in the denominator, so you would think 60. Nope, never ever, forever ever, anything that has a 6 in the denominator is 60 degrees. No man pound. So 30 degrees is pi over 6. This has a 3 in the denominator, so that's 60 degrees. So I don't know how you're going to do the figure to distinguish between power 6 power 3, but you gotta figure that out. If not, just use the calculator. Don't waste your time with that. So 3, 60 degrees. 6, 30 degrees. 4, 45 degrees. It's just that simple, y'all. Alright, so 3 power 4. Again, that's 45 degrees, and that's just gonna be power 4. So we just simply just look at the denominators. You got no time to figure anything else out, just do it. All right. So 5 power 4. Let's convert that to degrees. To convert from degrees, this is your reference angles. Ref angles. Make sure you guys know that. So that's the reference. But now let's go to degrees. So here, why don't you multiply 5 times 180 and then divide by 4. So 5 times 180 divided by 4 is 225. Okay? So 7 power of 6 just multiply by 180. Which is 1260. Divided by 6. It's just 210. Alright, so why don't you finish those other two by yourself and get back with me? So pause and you try it now. Alright. Hopefully you pause the video and try it. If you're not, please pause the video and try. And unpause it once you are done. Alright, y'all. I take it that you put in the work. So let's go ahead and go through with this. So let's do 5 power of 3. So 5 times 180 divided by 3. That's 300. Okay, so 3 times 180. That's 540 divided by 4. That's 135. Alright, so look, we just figured everything out. Now, you got any questions on these, because we've been talking about these for a while, just come see me or come to tutor. I'm at almost 52 minutes talking to you guys in this video, so let's move forward. Alright, so I left this blank, because I want to make sure that you kind of understand what's going on here. So, is 7 pi over 6, are these equal? Are these equal to each other? This is an essential question that I need for you to, show me. Go ahead and pause and try this one out on your own and then come back with me. I trust that you have paused the video and you worked this problem out. If you have not done so, please pause the video and just do it. It's okay if you're wrong, because this is how you learn. You learn mathematics by making mistakes. I know I don't want to get it wrong. Well, part of your grade is you showing a productive struggle. And you're not showing me that making the mistakes that you are learning this to master it, you're gonna struggle. Okay, so let's do this. 7 power of 6. I know for a fact that if I convert this to degrees, because that's what I want to do for each one, 7 times 180 is towards 60 divided by 6. I know that this is 210 degrees. Okay? And I know power of 6, which is 180 divided by 6, that's just 30 degrees. So guess what? They are not equal to each other. However, I do know by looking at these guys here that 210 is a reference angle 30 degrees because your denominator, I know, it takes me a little bit while to get this typed out. I think this is the reason why this video is long because of running everything out. Anyway, so this is what you have to answer. Are they equal? No, because 7 pi over 6 is 210 degrees, and pi over 6 is 30 degrees. However, 210 degrees is a reference angle because you got the same denominators. And we know anything that has a denominator of 6 is always and forevermore will be 30 degrees. All right, so here, you're going to have a situation like this that you have to answer. So I want you to answer this in the next 10 seconds or so. 33 over 65. And the reason why that's the case because we know that cosine is always the first coordinate pair. So that's how we know that. All right. Do this problem. Same seconds. All right. You should have, because this is sine. Sine is your second pair. All right. And we know about this sine of 45 degrees. Only thing that you have to do again, we know that both the legs are the same here, and we know that the hypotenuse is square root 2. So sine of 45 is going to be opposite over the hypotenuse, but we know that we can never ever, forever, ever have square root 2 in your denominator, so it becomes square root 2 over 2. And that's how you figure this out. Okay, I want you guys to try this one. This one's a little bit hard, but you could look at your unit circle and let that help you out, but you should know it. But yeah, put this in the calculator. Put it in the calculator, it should tell you something. Well, putting in the calculator is not going to necessarily work because it's going to give you a decimal answer. However, it's going to be 1 because you could actually round up and it gives you just 1. So you want to use the calculator, fine, but just know that it's going to give you a decimal, and you know when you see a decimal, always round up. So round decimal. Because from your calculator, you're going to get like 0.89. And of course, you're looking for a integer for your answer, so just round it up to 1. Now, that what I just did isn't technically a correct method to do, but if that will help you, to memorize for it, I'm all for it. Because at the end of the day, as long as I get 1, I got no issue with you. And this is how you come up with it, that's cool. All right. So this is easy for you to do. Do it in 5 seconds. I'm telling you to do it right now in 5 seconds. So let's go. 5, 4, you about to answer this question. 3, 2, 1. You shouldn't have gotten pi over 6 because the question asks you to find the reference angle in the radians angle. Radians. And we know for a fact, we know pi over 6 is 30 degrees. That's degrees. But however, if I want you to give it to me in the radian angle, you want to use pi over 6 because 6 is in the denominator. Alright, we're almost done, y'all. I know this is a little bit long, but take it as what you need it. So sine is all these shear functions are positive. Sine is positive. Tangent is positive in quadrant 3, and cosine is positive in quadrant 4. So just remember all of this. Alright, so in some classes, not all, we talked about this just a little bit, about periods and amplitude. So your A being your amplitude, gotta look at your graph. So where is the highest point? So at the highest point is going to be at 1. So you could say equals 1, or when F for 30, or not 30, 90 equals 1. So that's that. So you can write that anyway. But let's look at the period. So the period, you're looking for when at 0. You're looking at 0, and you're looking for when it makes one complete cycle. A cycle means that this is where it starts at. And you notice when it starts at 0, the graph increases, right? So what you're looking for, and that's me trying to draw an arrow, you're looking for when does the graph intersects at 0, but when does it rises at when it has an x-intercept. So here, I don't mean you guys to go 180, but that's a problem here. See how this decreased? But in my starting position, I increase. So therefore, it's not at 180. However, if I look at 360, I realize that my graph increases, and that's my complete cycle. So you can say, for my period, I got 360 degrees. So that's 360. Because again, it starts here at 0, but rises up, and it rises up. Alright, yeah, what's the period of this amplitude? Period. So, give you 5 seconds to answer this question. Alright, but now you should already know what it's going by. So, again, I start at my 0 point. I know that my amplitude is at 4, but however, what I'm looking for, when it's at 4, that's what I need to look at. When it's at 4, when is this case? When does it make its complete cycle? When y equals 4. So when I look at this at 0, 4, the graph decreases. So I'm looking for when it starts at 4, when does it decreases? So here, when it's at pi, I get 4, and that decreases. And then when I go to 2 pi, it decreases. And then when I get to 3 pi, it decreases. So that period is going by pi. All right, you do this in your calculator. So pause video, do it, and do it in Desmos, and just meet me there. Alright, I hope you did this. If you have not, please do it. Remember, you're not helping yourself if you're not trying to do this to get the understanding of it. So this is what you get. You get 3 power of 2. Well, not 3 power of 2. You get power of 3 as the period. The amplitude is at 2. Amplitude is at 2. Your period is pi over 3. And the best way to do the period is always to put it in the graph and look at its repetition cycle. Because this is one complete cycle. Alright, put this in your calculator in decimals and see, do you get 1 as your answer? Do you get x equals 1? Take your time, do this. I know you've been with me for an hour, but I need for you to keep this up because this is critical that you understand this. Because this is still ACT stuff we're covering, although, you know, we'll be doing Algebra 2 stuff. If you got x equal 1, good job. Put this in correctly. Be careful. Make sure you give yourself space between the equal sign and the radicals. Otherwise, you're not going to get the correct answer. Alright, so look. In your test, in that particular, you're going to have situations where your x becomes like t, z, h, anything. The question is, how would you put that in decimals? Remember, always plug it right in for x. So in decimals, you should do 4x squared plus 3x plus 9 equals 11. That's what you have to do. Do that, and you can get your answer. So again, all the letters are switched with x. So when you put this in decimals, you get something like this. However, what you have to do, y'all, you have to put in the fractions you get in decimals, on your multiple choice, to determine which one matches the decimal point. So when I click here, when I type in my fraction, and I click this sign right here, I get 47 over 40. So anything that gives me my decimal point is my correct answer. So again, any fraction that you get as a multiple choice option, if it gives you the answers that you got here in decimals, those are your answers. If you need further assistance, of course, come to my tutoring. Make sure you write questions down and we could talk about it. Alright, y'all, thank you so much for rocking with me, because I know this is a long video, but it needed to be long for those purposes about that ANET, ACT. Everything that we do in Algebra 2 is still part of ACT.